Alright, so in this assignment we are looking at some of the topics we've already kind of talked about in the last section, a little bit about graphing. We're getting a little bit more practice, a little bit more in depth with some of that. Specifically, we're going to look at linear equations or linear graphs. And this is just kind of a mix of information from different sections. We don't have a real good section in our textbook for this stuff, so this is all kind of from all over. So that's why we don't have a lesson number with this one. Okay, so the first thing, and this is kind of a review, but the first thing for us to talk about is when we have the coordinate plane, where we're talking about graphing things, we have an x-axis and we have a y-axis. I know we talked about this last time, and when we have a point, we have an ordered pair. It takes two numbers to identify a point in the plane. First, we need an x-coordinate and then a y-coordinate. So we always do the horizontal first, the x's, and then we do the verticals, the y's next. Okay? And so over here, positive is to the right and up, negative is to the left and down. And so here, all of our xy pairs are going to be, all of our xy pairs are going to have a positive x and a positive y. Okay. Over here in this section, we'll have negative x values because we're to the left and positive y's because we're up. Down here we'll have negative x's because we're to the left and negative y's because we're down. And then the last place we're going to look at, we'll have positive x's because we're to the right and negative y's because we're down. We call these the four quadrants of the xy plane. We call them quadrants because there's four of them. And we label them using Roman numerals. So this is quadrant 1 with the Roman numeral I. Then we go counterclockwise. So this is quadrant 2, II. This is quadrant 3, III. And then the last one is quadrant 4, so that's IV. Okay, so you have a couple questions asking what quadrant something's in. So that's 1, 2, 3, 4, and you can figure that out by looking at the signs of x and y. Okay. And then there's a problem asking you to plot points. So you do x first and then y. And we kind of covered that in the last video. So now we want to talk specifically about straight lines. What kind of equations we have, different parts of the equation when we have a straight line graph. The first thing we want to talk about is the slope of the line. Slope, and that's an E. That doesn't really look like an E there. Let's fix it. Slope of a line. So there's really four types of slope we can have. Let's see if we can fit 4 XY planes on here. I'll make that one a little smaller. Okay, so the first type of slope we can have is if we're looking from left to right. If our graph moves up, if it rises from left to right, that's what we call positive slope. And so if it increases from left to right, that's positive slope. If we have a graph that decreases from left to right, and so as we go from left to right, it moves down, we call that negative slope. And most lines are going to be either positive or negative slope. But we do have two kind of oddball situations, and they do come up. So one kind of weird thing that can happen is if we have a horizontal line, it doesn't go up or down as we go from left to right. So we say that this has 0 slope. Okay. And then one more, if we have a vertical line, and so it goes straight up and down, we say the slope is undefined, so it doesn't fall into either one of any of these three categories we've talked about. It's not positive, negative, or 0. It's undefined, and we'll be able to see why that's undefined here in just a second. Okay. So if you see a graph, you need to be able to tell if it has positive slope, negative slope, 0 slope, or undefined slope by looking at how it rises from left to right. We also want to be able to calculate the slope of a line. So remember, we're looking at how much a line, or how a line goes up and down when we move from left to right. So unfortunately, our symbol for slope is m. Okay, I think it goes back to a German word for mountain. Okay, like a mountain slope. So our symbol for slope is m, and the way we get this is we want to talk about how much our line goes up and down, up or down, versus how it moves horizontally. So we talk about how it changes vertically compared to how it changes horizontally. A lot of times we call that rise over run. And the way we calculate that is we'll need 2 points on the line. Okay? And we take the y coordinates and we subtract those. Usually we write it y2 minus y1. So we say how much does our line change vertically? And we divide that by how much our line changes horizontally. So x2 minus x1. Okay, so x1, y1, that's 1 point on the line. And then x2, y2 is another point on the line. If we have 2 points, then we can figure out the slope of a line. Okay, so let's do one. We can put a number on it. So we want to find the slope of a line that has these 2 points on it. So we'll say that contains, then we'll list out our 2 points. So our first point is 4, 3. And the second point that's on the line is -2, -1. Okay, so we're going to use our formula we just talked about. I highly suggest when you have the 2 points, you label them point 1 and point 2, so you don't get mixed up in the formula, because if you get stuff backward, you'll get the sign wrong. Okay. So here I'm going to call this one point 1, so I'll say this is x1, y1. And then this is point 2, so I'll call this x2, y2. It doesn't matter which one you call point 1, which one you call point 2. You just got to be consistent. You got to keep the 1s together, and you got to keep the 2s together. Okay. So here's our formula again. I'll write it down again. y2 minus y1 over x2 minus x1. You don't have to worry about memorizing this formula. I will give it to you. You just need to know how to use it. Okay. So y2 is -1. Then the formula says minus y1 is 3. So we got -1 minus 3. Okay. And then we got x2, which is -2, minus x1, which is 4. Okay. And we get our slope. So -1 minus 3, that's -4. -2 minus 4, that's -6. A negative over a negative is a positive. And then we can reduce this fraction. So 4 over 6, we can divide top and bottom by 2. Get 2/3. Okay. So let's look at our slope for a minute. 2 over 3. So this tells us every time our line moves 2 units up, because it's positive, okay, that we're also going to go 3 units to the right, because that's positive. Okay. That's what that's telling us about our line here. Every time we go 2 units up, we're going to go 3 units to the right. Okay. Really quickly, let's talk about being careful here. Let's look at what happens if we switch the 1s and the 2s, right? What if we do the points the other way around? So what if we called this one, I told you it doesn't matter, right? You'll get the same answer. What if we call this one x2, y2, and this one x1, y1? Okay, so if we do that, it's just going to switch the order, but I'm trying to make a point here about being careful with the signs. It's the goal. So here y2 is 3, and it says minus y1, but y1 is -1, so you have to be careful with the signs there. And x2 is 4 minus a -2 for x1. So again, you have to be careful with the signs there. And then here, the double negatives turns into 3 plus 1 and 4 plus 2. And we do get the same thing. We get 4 over 6, which is 2 over 3. Okay, but just be careful with those signs. Okay, because since we have the minus sign in the formula, anytime we have a negative number after that, you have to take care of the double minus signs. Okay? All right. So how does this slope come into play talking about the equation of a line? Okay, well, one way we can write down the equation of a line is what we call the slope-intercept form. And a lot of you probably remember this form. You might not remember the name. But that is when we put our equation in the form y equals mx plus b. Okay, so here we already talked about m. That's the slope of our line, rise over run. And then b is what we'll call the y-intercept. So what is the y-intercept? Well, the y-intercept is where the graph crosses the y-axis. So where does our graph intercept, or where it crosses the y-axis? So we get y-intercept out of it. So that's going to be a point. And since we're crossing the y-axis, the x-coordinate of that y-intercept is always going to be 0. Yeah, it's always going to be 0. So our y-intercept as a point looks like 0, comma b, whatever b is. B is just a number. Okay. So let's look at one here. So here we've got the equation of a line, y equals 2x plus 3. Okay, so from looking at this, I know that my slope is 2, or 2 over 1. Sometimes it helps to write it as a fraction. And then my y-intercept is the point 0, comma 3. Okay, so this is enough for us to graph this line. Let's see, I think I've got some graph paper saved here. Now, so let's see, paste. There's just some graph paper. Let's see, a little bigger. There we go. So now our graph will actually look decent. So this is enough for us to graph this line, okay? Because we know our y-intercept is at 3, so we're going to go 1, 2, 3 up on the y-axis, so that's our y-intercept. And then we know the slope, so remember this says we're going to go 2 up, 1 to the right. So we can find another point on our graph. So we're going to start at our y-intercept. We're going to go up 2 and 1 to the right, so that means that point is also on the graph. Okay? We can also go up 2 more and 1 more to the right. That point's on the graph. Okay? And then another thing that's handy sometimes is you can go backward also. So you can do the reverse. So instead of going 2 up, 1 to the right, we can go 2 down, 1 to the left. And 2 down, 1 to the left. And then this gives us our line. And I don't have a ruler, so let's see how good I can do here. There's our line. That's our graph. Okay. You can also use this idea in reverse. Okay. So let's see. Let's make us one. We'll make a problem up here. Okay, so we're going to graph a line, and then we're going to figure out the equation. Okay. So let's see. Okay, so here's the line. Sorry, it's wiggly. Okay, but I've shown 2 points. It's on here. Okay. So how can we get the equation of our line? Well, we need two things, right? We need to know the slope. We need to figure out m, and we need to know the y-intercept. Okay? The y-intercept's pretty easy, right? The y-intercept, I got white, so you can't see that very well. The y-intercept is down here. So what's this point? So that's going down 2. So our y-intercept, -2. Okay. Now I need to know the slope. On my graph, it's a little trickier because my line's not straight. Okay, but what you can do to find the slope from a graph is you start it anywhere where it crosses right on the grid, where you know that point's on the line, and then you find another place where it's right on the grid, and you just count up and over. You'll get the slope. So I'm gonna do colored dots so you can keep up where I'm at. So I'm starting down here at the y-intercept. Because my line's wiggly, the only other point that I'm sure on the line is the other point that I've got drawn on here. Okay, so I'm going to count up and over to it. So I'm going to go 1, 2, 3, 4, 5, 6 up. That gets me to here. So I know I've gone 6 up. And then I've got to go 1, 2, 3, 4 to the right. So that is my slope. And sometimes if you, especially if you don't get the first 2 points you see, then you'll get something that needs to reduce. So we can simplify this, right? We can divide top and bottom by 2. So my slope is 3/2. Okay, so what's my equation of my line? That's y equals mx plus b. And then we're going to plug in for m and b. So y equals 3/2 times x. That's okay for it to be a fraction. And then plus -2. Or we don't have to write it that way. We can write it 3/2x minus 2. So there's the equation of my line in slope-intercept form. Okay. One other way that we can get the equation, or one other form we're going to look at of getting the equation of a line here. And so we did the slope-intercept form. So now we're going to look at what if we don't have the y-intercept? What if we just have some point that's on the line? That's what we call the point-slope form. Point-slope form of a line. So here we're not necessarily using the y-intercept, we're just using some generic point. So here we're going to have y minus, I'm going to write this in a different color, I'll tell you why in a second, y1 equals m times x minus x1. Okay, and the reason why I wrote those things in red was because those are the numbers that you're going to fill in. Okay, so when we're filling in here, we're going to know, we're going to know that our slope is m. We need our slope, and then we just need a x1 and y1 that comes from just some point that's on the line. So that point on the line. So how can we fill in here? Okay, let's look at one. Alright, so let's say we have some line and we're told the slope -8, and we have a point on the line. Point that it gives us that's on the line is -2, -3. Okay, well, here's we have a point and we have a slope, so we can use the point slope form. Alright, so here we want m. Okay, we know m is -8, so -8 is going to go here. And then again, it's probably a good idea to label these. This is x1, y1, just so you don't get x and y mixed up. So y1 goes here, so that's -3. x1 goes here, so that's -2. Okay. Then we can get rid of our double negatives, so this could be y plus 3 equals -8 times x plus 2. Okay. and that's the equation of our line in point-slope form. If it tells us to put our answer in slope-intercept form, y equals mx plus b form, then we need to distribute on the right side. So we'll get negative 8x minus 16, and then we need to subtract 3 from both sides to get the y by itself. So your y equals negative 8x minus 19. That would be our line in slope-intercept form. So it could tell us to put it in point-slope form. That's this one. Or it could say y-intercept or slope-intercept form. That's this one. Okay. So all we need is a slope and 1 point on the line, and we can get the equation. What if it gives us 2 points? If it gives us 2 points, first find the slope using the slope formula, and then use the slope in either one of the points. Okay, it doesn't matter which one. And then the last thing to talk about here is the idea of parallel perpendicular lines. The parallel lines are when we have lines that look like train tracks where we say they're never going to touch each other, right? So parallel lines have the same slope. So if one has a slope of 4, the other one's going to have a slope of 4. Okay? One has a slope of 1/2, the other one has a slope of 1/2. Perpendicular lines are when we have lines that meet at 90 degrees. Okay. And perpendicular lines have what we call opposite reciprocal slope. So that's a fancy way of saying you flip the slope and change the sign. Okay, so if we have the slope of line 1, okay, if that is 1/4, then the slope of line 2, if they're perpendicular, the slope of line 2 would be negative 4/1. And we flip it and we change the sign. Okay? Or if we had the slope of line 1 is negative 2/3, negative 2/3, then the slope of the parallel line would be positive 3/2. You change the sign and you flip it to get perpendicular. For parallel, they're going to be the same. So whatever the slope of one line is, that's the slope of the other. Okay, I think that's everything you need for this section. Let me know if you have questions.